Once upon a time, there was a calculus student whose name was Goldilocks. One day, Goldilocks was studying for the AP exam when she saw another student's homework. She tried to ask for the other student's answers, but the student said no, so Goldilocks waited until the student got a drink of water. Said Goldilocks. I'm sure this student wouldn't mind if I took a quick peek at their answers. Goldilocks flipped the page 3 times to find the answers, and on the 3rd page, she found the problem. Then she saw the answers, and she was still confused, so she decided to look over them. In the homework sheet, there were 3 solutions to the calculus problem f of x equals x squared. The problem said this: using a Riemann sum, find the approximate area that forms under the curve from x equals 0 to x equals 4 using 4 subintervals. The first answer used a lower Riemann sum to solve the problem. With a width of 1 for each subinterval and endpoints of 0, 1, 4, and 9, the equation was set up like this. When Goldilocks saw the answer, she noticed that the rectangles on the graph went below the curve. This was not a satisfactory answer.
It is an underestimate!
The second answer used an upper Riemann sum. With the width of 1 for each subinterval and endpoints of 1, 4, 9, and 16, the equation was set up like this. Noticing that the rectangles went above the curve, Goldilocks was unsatisfied with this answer and said,
Overestimate!
The third answer used a middle Riemann sum. With a width of 1 for each subinterval and endpoints in the middle of each subinterval, the equation was set up like this. Upon seeing the answer, Goldilocks realized that it was the closest approximate between the 3 solutions and said,
This answer is just right!
Now Goldilocks finally understood the purpose of a Riemann sum. It is supposed to approximate the definite integral, in other words, the area under a curve. This is done by drawing several rectangles in between each subinterval and using the distance between each subinterval as the width and the height as the point of the rectangle that rests on the curve. By calculating the area of each rectangle and adding the sums, one can find the approximate area under a curve. Goldilocks copied the answer into her notebook. However, the student who wrote the work returned to her desk and saw Goldilocks sitting in her seat. She told Goldilocks to go away. When Goldilocks saw the student, she immediately went back to her seat. Satisfied with the solution, she never looked at the other student's homework again.